what I do want to do is to do what is really a picture slideshow. There's going to be writing on these, but I don't think you should read the writing. Look at the pictures. And what I'm interested in is to trace the history of exploration of the Earth and now space and the cosmos. There's a straight line that starts in Greece with Aristotle and winds up with what we are doing today. I'd like to go through that, and I will hopefully work this laser pointer correctly. There we go. Okay. The necessity to explore. I think it is a necessity. I think it's in our bones to explore. And of course, I think St. Matthew said it better than anybody. Ask and it shall be given, seek and ye shall find, knock and it shall be opened to you. And then in the 8th verse, he's optimistic. He says, anybody who asks will receive, receiveth. Everybody who seeks will find, and everybody who knocks will have an open door. And I think that certainly in my own lifetime, I've tried to follow that rule. The substance of what I'm going to say is that we're going to describe the exploits of about 25 people who led the exploration of the Earth and then later the pioneers in space. All of them either made or helped others make crucially important discoveries for the first time. That is, it's terribly important to be first, and that is where our civilization really shines. And all of them were products of our civilization, and as I'll show you, I don't think anyone else can make the same claim. Aristotle's first. Aristotle was born in northern Greece. He became a scholar, spent 20 years with Plato in his academy, disagreed with Plato over the state of the world and said the right thing to do is to do experiments and to do experimental things. And Plato said, well, you learn everything by thinking deeply about it. That may be true, but Aristotle didn't like it. And so Aristotle actually conceived the first model of the cosmos. And here it is. It's quite simple. The Earth is, here it is, finite and flat. It is surrounded by 3 translucent spheres. The stars are on the outer one. The sun is on the next one here, and the sun has to be on the next one because it does not revolve around the Earth in exactly 24 hours, or it is a little faster than the stars. And it goes, as you know, through the zodiac, the signs of the zodiac every year. And it returns to the same place. And then the moon is the 3rd sphere, and this one only takes a month to go around the Earth. And so you have a crude but accurate in terms of the observations you could make model of the cosmos. Aristotle also said another thing, which later on caused some trouble. And that is that all these motions that I talked about have to be circular and uniform. Uniform, circular motion. And keep that in mind because it took about 1,400 years to figure out that that wasn't quite right. Okay. The next character I'm talking about is Eratosthenes. He was the first one who made a change in what Aristotle said, and whose change was also experimental. He said the Earth is not flat. he lived in Alexandria, he worked in the library there, and he saw Alexandria as a big harbor. The northern part of Africa at the time was the breadbasket of the ancient world. So there were lots of ships coming in and out, and they came over the horizon. They saw the masts first, and then the rest of the ship. And he said the Earth is a sphere. Not only that, he measured the circumference of that sphere, and he did that. He did that by doing this experiment on the summer solstice, June 22nd. He had that the sun is perpendicular here to the Earth, so there is a 90-degree angle between the ray. But in Alexandria, which is 800 kilometers away, the sun is not perpendicular, and there's a 7-degree angle between these two. And from that 7 degrees, Eratosthenes was able to calculate the circumference of the Earth, and he got pretty close. So from then on, and mind you, this was in 200 BC, the notion that the Earth is flat was gone because there was an experiment that showed it was there. And this is something that, of course, I'm going to come back to several times, because there were people who believed it and there were people who didn't, and then there were people who thought that Earth had the wrong size. The next one is Ptolemaeus. Ptolemaeus was a resident of the library in Alexandria, and there he wrote a book. He called it the Almagest. That basically meant the book of everything. And in that book, there was the first model of the solar system that was different from Aristotle's. And I'm going to show you the picture. This was the solar system of Ptolemaeus. Of course, the Earth was at the center. The moon was next. Uniform circular motion. It turned out the moon wasn't quite uniform and circular. And so Ptolemaeus put a little other circle here that had a different radius and also a different speed. And so he could kind of cobble up the way the solar system worked. The sun was up here, and he had to put that here because there were 2 planets that never got far away from the sun. And so this line here rotated around the Earth along with Mercury and Venus, of course. And then Mars is here, and Mars is important because it has the largest epicycle. Ptolemaeus had to give Mars the largest, what was essentially a deviation from a constant motion, the circular orbit of Mars. And later on, you'll find out that this happened, this large aberration here was necessary because the orbit was in fact not circular. And we'll get to that shortly. And of course, the rest of the planets were here was Jupiter, and here is Saturn there. Here. Okay. So this was his model of the universe, and it was accepted as being correct for something like 1400 years. This was done in about 120 AD, and it wasn't until Kepler came along that things changed. And we'll explain that shortly. Ptolemaeus also made a map, and this is the first map that showed the Earth as a sphere. Now, you can't put a sphere on a flat plane of paper, but this is a projection of the Earth, and Ptolemaeus actually made this map, and so it was an important first in the creation of how the Earth really looks. It's pretty distorted, as you can see. The Mediterranean is up here. Here's Spain. Spain's a big country. China is a pretty small area over here. So he had some dimensions wrong, but he tried. Okay. We come now to a period where Europe was really under stress. The library in Alexandria was destroyed. Roman Empire fell in 476 AD. Mohammed created the new religion. And Europe essentially retreated until after the turn of the first millennium. And it kind of recovered at that point. And the recovery started with Marco Polo. This is an explorer. Marco Polo's father was a wealthy merchant. He had been to China twice, and he was the first one to get to China. And then the Kublai Khan had him and told him about the Pope, and he had Kublai Khan had said, well, I have to send a message to the Pope, and I want you to deliver it. And so he did that. And then a little bit later, the Marco Polo's father and son spent 17 years on the second trip to China, which was the one that young Marco Polo went on. He was 17 years old when he started. They spent it, I think, also 17 years on that trip. And what Marco Polo did that nobody had done before, people had gone to China before, but what nobody did was to write a book about it. And to write a book that tried to be accurate in terms of the distances that were being covered. And in this picture, this is how they went there, they walked, and then how they got back by sea. And the Chinese had a long maritime tradition. And the interesting thing about it is that it was shut down abruptly during the Ming Dynasty. The Chinese sailed, they had much larger ships than the Europeans, but there was an edict from the emperor. The emperor said, we are the Middle Kingdom. Other people should come to us. We won't go to them. And so they really stopped the maritime tradition that they had. This is a page from Marco Polo's book, and I'm showing it here only for one reason. And these notes here were written on this book by Christopher Columbus. Columbus was already thinking in 1480 about sailing and about how you might get to places. And so he carefully read this book, annotated it. This gentleman is very important. He was really the person who invented the way we do business in research or exploration. And the idea was, first of all, he was the son, the third son, I think, of the king here. This is King John I. This lady is Philippa of Lancaster. She was an Englishwoman, and she was the daughter of Duke John of Gaunt. He was the Duke of Lancaster. And so there was a British connection between these folks. And Henry decided, after going on a military mission, that sea power would be super important and that he would develop the art and science of navigation. He would start that development. That was a conscious decision on his part. His father agreed with doing that, and this was the area where he started. He became the governor of this province, the southernmost province of Portugal. And then here in Lagos, this is the Cape St. Vincent, and there's another cape right next to it, which is called Sagres, the Sacred Cape. And this was the area of his first explorations. Now, what did he do to make exploration possible? Well, here's a picture of his place. This is where his laboratory or institution was. And this is where this is the same picture up here. And this is the town of Sagres. And here he had shipyards, and he had people that made barrels, and he had people that made instruments, and so on. And this became then a center of the study of navigation. And here are some of the achievements. The most important one actually was this one here, the Caravel. This was a ship that combined the hull of a seagoing Atlantic ship with the rigging, this triangular rigging of the Arab dhows. And so you could change this ship to one that could tack by just taking the sails off and putting them on this way. And I'll show you some pictures of these things later on. And then there were, of course, maps, instruments, and the best description in a few sentences that I found is this one here. At Sagres was thus founded the systematic study of applied science in Christendom. It was better than the work of the old university, and I think these meant the library here in Alexandria, with which it has been compared because it was essentially practical. In other words, it's what we call a mission-oriented research institution. And he really built this thing up. And always when I joined NASA, I said, my God, I'm running one of these places. And so it was quite interesting. Okay, what was the first experiment? Henry asked one of his captains to prove that a caravel could sail in any condition and make this trip in a short time, make it quickly. And here is what it says, the probable course. First leg, the ship goes here, following wind. On the second one, he had a broad reach. Here he had to tack. That was a beat. And then this was a downhill. When he came back quickly, Henry started to send out his captains down the coast of Africa. And here we are. And Henry died in 1460, and by that time he had gone down to Sierra Leone. Now, Henry died, but the institution continued. As you'll see, this institution was later completely destroyed by Francis Drake. You've all heard of the singeing of the beard of King Philip. That singeing was an attack on Sagres and Lagos. They put 1,000 people ashore to burn that place down and destroy it. And the reason, of course, is that Drake and the Lord High Admiral, Lord Howard, all these people knew how important an institution like this was to seafaring. And Britain was going to be the first seafaring nation, not Spain. And I'll talk a little bit about how that happened later on. This is, by the way, a caravel rig, the lateen sails. Bartolomeo Diaz was the next captain that did something important. He was asked to find out how far a caravel like this could sail on the open ocean. And that depended on the amount of water it could carry. people can live quite a long while without eating. But if you don't have water, you die in a few days. And Henry, of course, in the Institute, was very interested in barrels. And why? Because he wanted to make barrels that kept the water fresh. That is, that had substances in them that would do that. No creepy crawly things. And what Diaz learned was, is shown here on the next slide. This is his first voyage around Africa. Of course, I should say first why they wanted to go around Africa, because the reason is they wanted to go up to India and to the wealth of the Far East by sea. And the Phoenicians had probably already circumnavigated Africa, but that was lost. And this was rediscovered. But the main point is, on the first journey, he went way out into the Atlantic, 5,000 miles, and wound up here, then about 2,000 down to here, then he city hopped here, and finally wound up at the Cape. And that the range of a caravel now was something of the order of 4,000 miles at sea, was taken as a given, and from then on, it's not an accident, ladies and gentlemen, that if you look at the Portuguese colonies in what was Africa before decolonization, they were all about 3,000 miles apart. You had the colony up here, then you had Angola, then you had Mozambique, and from there you went to India. That was the trip. Next person was Vasco da Gama, and the people at Sagres said, okay, now you go to India. And that's what he did. And there's not much more to say about that, except that this map is the legacy of the Portuguese explorers. What they found were the Coriolis force rotations of the ocean. These are ocean currents. Here's another one. Notice that this one, of course, runs in a different direction than the other one. And also they discovered the monsoons, which runs one way in the spring and the other way in the fall. And so they had this map to guide them in their voyages. Okay, now we're going to change a little bit and talk about Columbus. Columbus had one important feature. He was not a Portuguese. He was an Italian. And he came from a merchant family, and at a very early age he went to sea, and he was a trader. He traded with all kinds of people. He went to England, he went to what was today France. There is some evidence that he actually went to Iceland once, but that's not very confirmed. And he had this map that a priest, this is the Framoro map of 1460. One of the interesting things about this map is how much they underestimated the size of the Earth. Look at this is China here. Here's the Mediterranean. 2 Mediterraneans and you're in Viking. Okay, that ain't so. I show this map because people speculated. And if you have not perfect knowledge of what's going on, you will see that Columbus indulged in a speculation. Now, here, what were the questions? What is the circumference of the Earth? Eratosthenes had it. But what's the distance measure that he used? Did he use the Arab mile or the Roman mile? So there was a discrepancy here. And then the other thing was, how far is the east coast of China from the west coast of Europe? And that, of course, depended on the size of the Eurasian continent. And at this point here, about 1482, Columbus received a map from this fellow here, Toscanelli. He was one of his friends. He was a physician. He was Genoese, Genoa. They were both from Genoa. And so he got this map, and I've got a kind of a reproduction of it here. This is not the map that Columbus had, but this is a replica of it showing the distances that Columbus thought he had to cover. And here was the problem. That first of all, how far did Marco Polo go? Ptolemaios said that the landmass ended at 180 degrees. He said that's very simple. If you go east, it's all land, 180 degrees. If you go west, it's all ocean. And that was his speculation, all right? Toscanelli, on the other hand, got a hold of another manuscript, Marinus of Tyre, who said the continent is even bigger, 225 degrees longitude. Now the actual distance is 115 degrees. So he was overestimating this thing almost by a factor of 2. Columbus said, that's it. Okay. Marco Polo made a long trip. Here is Cathay, China. Sipangu, that's Japan. That was the name for Japan at the time. Marco Polo got to Japan, actually. This distance is about 4,000 miles, and lo and behold, the caravel can travel 4,000 miles if the water holds up, and Columbus was willing to take that risk. So Columbus went back to the people at the Sacred Cape, Henry's Place, and showed them that this is the real Earth here. Okay, here's Japan, here's Spain. Now that's what it really looks like. And Columbus insisted that this was it, and he used the Roman mile because the Roman mile is smaller than the Arab mile in order to make the smallest possible distance between Spain and Japan.
So Shelley idea.
Well, he cooked the books a little bit, but he wanted to do it. By the way, this story is from Samuel Eliot Morison. If anybody here has ever read the book, the Columbus biography, it's a wonderful book. And he describes this whole thing in great detail. So what happened next is that Ferdinand and Isabella kicked the Moors out of their last stronghold, the Alhambra in Granada. And so the Moors were out of Spain. And Columbus said, aha, the people at Sagres don't believe me. They think the earth is too large. I'm going to go to these folks and try to get some money. They won the war, so they had achieved a victory. And when he got there, sure enough, they gave him the money. And here is the fleet. And once again, I point out to you the rigging of these ships. This was the Santa Maria. It had a lateen rig here, and this mast could also be rigged with a lateen sail. And then, of course, they didn't put the square sail on this mast. These two were ships with a square sail. This one was completely, the Nina was completely rigged as a lateen sail ship. And so Columbus went, here he is. He landed on what the British later on in the Bahamas called Watling's Island. He called it San Salvador. And he made a shrewd move. He took some native people from here, and when he got back to Lisbon, he could go to the king and say, look, I have found the Far East. This is Japan. These are the people that live there. And I can imagine the consternation in Prince Henry's place because here were the experts. And I think their first reaction was, oh my God, he's right. And there is a record in the library in Lisbon that the first thing they did when Columbus landed was to remeasure the radius of the Earth, the circumference of the Earth. And of course, they got the same answer that Eratosthenes got. And so they knew immediately that Columbus had discovered something new. And as you know, Columbus never realized that that's what he did. He always thought, for 4 voyages, that he was in the Far East. And that's why, and of course, the story of Alexander VI, the Pope, that drew the line between Spain and Portugal, and the reason why people speak Portuguese in Brazil is that that line ran through the country, and so everything to the east belonged to Portugal, and the stuff to the west was Spain. So, we now talk about England for a little bit, because the Spanish domination of seafaring and the Portuguese, of course, Portuguese and Spain, you know, came together, that there was only one Spain. It was Portugal for a long time. That was part of Spain. And that circumstance came to an end when King Philip II decided to invade England. Henry VIII had already anticipated that because he had left the Catholic Church. And so he built a shipyard just to the east of London here in Deptford. This is what the yard looked like 100 years later. It was a major naval shipyard. And then in 1588, the British Queen, this is Queen Elizabeth, this is Lord Howard, the Admiral, this is Francis Drake. And Drake said, hey, they sent him to sink some ships in Cadiz, and he sank a few, but this was so big he couldn't do it with 20 ships. But then he went to Sagres and burned the place. And of course, the rest of the story you remember is that the Armada was sailed up the channel. And I really can't prove this, but I believe that this was especially anxious. He landed 1,000 men out of those 20 ships he had. And the destruction of the Armada was really the end of Spanish domination of the sea. We're going to change stories now and talk about space. And to get ahead of the story, it was Galileo who first realized that there was space. You know, the concept of space, if you're sitting on the Earth, is pretty hard to do. But Galileo, well, let me tell the story first. I have a picture later. I really should do this first. Galileo was later. Copernicus, to make the long story short, was the one who really put the sun at the center of the solar system. And the interesting thing is that he did not do that for physical reasons, he did it for practical ones. I talked about the Ptolemaic solar system. I talked about these epicycles. This period was when the 30 Years' War was about to start between the Catholics and the Protestants. The Pope, the sitting Pope, Pope Leo X, was desperate about having a war between his people, the Christianity. And so he went to Copernicus and said, look, one of the reasons why Europe is so disunited is that everybody has a different calendar. You know, you could be in one principality on April 3rd, and then you cross the border and you are on May 22nd. That was the condition. And he appointed Copernicus as a consultant to the Fifth Lateran Council that met in 1513. And it was during that council that Copernicus began to talk or think about the solar system. And his objective was to reduce the number of parameters necessary to get the right answer. Because if you put the sun in the middle, then none of the complications that I showed you in the earlier picture was there. Here is Copernicus' solar system, sun in the middle, Mercury, Earth, and so on and so forth. He published a little book. He called it, let's go back one. This is the book here. Here. It's called Commentarialus. Here's Pope Leo X, who called this whole thing. And this book was immediately accepted by the church because it solved a problem they had. Copernicus, on the other hand, began to think and to, and he knew about Occam's razor, namely, if something is simpler, then it's probably the right thing. And eventually he came to believe that the solar system was indeed heliocentric. And here we are. Here is his book. This is the Revolution of the Heavenly Bodies. And he said, I'm not going to have this book published until I die, because I'm a church lawyer, and boy, am I going to be in trouble if that happens. And sure enough, the book was published after he died. And by the way, it got the imprimatur. And the reason was simple: people didn't understand it. And 100 years later, they threw the imprimatur. Okay, now Galileo. Galileo was important. The most important thing he did was this. This was a telescope. He learned how to build telescopes from the Dutch. And this was a big instrument, about 5 feet long. And it had a magnification of about 30. And a good binoculars will give you that magnification. And in 1610, Galileo turned this telescope to the sky. And here's what he saw. The moon. The moon has mountains. It has seas. He called them the mare. It looked like the Earth. Venus has phases. Well, Venus never gets very far from the sun. And the Earth is outside, and here is the morning and the evening star, depending on what season it is. But the real killer was looking at Jupiter. There is a page in that book that Galileo, his notes, where he shows how he measured the circular, the orbital time of each of these moons. And then he said, look, here is a model of the solar system. This is something that exists. You can no longer believe in the Earth-centered universe. And for that, of course, he got into trouble. And he was, and here he really came to the conclusion that this thing here, the moon is far away. There's something in between the Earth and space. Moon is a body like the Earth. He saw it. So he was really the first person then to contemplate the idea that space was an arena where things happened. And this is the end of the story. This is Pope Urban VIII. His real name was Maffeo Barberini, and he and Galileo were buddies at the University of Padua. Not only that, when Galileo moved to Florence, he was the Cardinal of Florence. They were good friends. Well, the Inquisition got to Galileo. They convicted him of heresy. But the Pope was the one who decided the punishment. And the punishment was house arrest. House arrest in a villa above the hills in Siena, I think it was. A walking distance from where his daughter lived in the convent. She was a nun. Here is Urban VIII. And that was Galileo's punishment. And in the 8 years he lived there, he got to be quite old, he actually made some scientific measurements and discovered that the lunar axis has a little nutation. So he kept working while he was being punished. And incidentally, this is a story that is also very well described in a book by an Italian professor called The Crime of Galileo. It's an old book, but it tells this whole story. Now, this is now the really interesting part. This is Cyrano de Bergerac, the guy with the big nose. He wrote a book about going to the moon. He called it L'autre monde, the other Earth. And in that book, there is a picture of man sitting in a box. Guess what these are? He's going to the moon with a rocket. 1759, I think, or 1659. 1659. First time that somebody had thought of the idea that space is someplace you could go, and that the rocket would be the propulsive system. Okay, now we got one more difficult thing. Well, Tycho Brahe, he was the one who measured the orbit of Mars so accurately that when Kepler came around, Brahe was a friend of the king, and the king built him an observatory on this island in the here. Copenhagen is down here. This is Tycho Brahe. Notice his nose. He was a hellraiser when he was young. He got into a duel and his nose got cut off. And so he was famous around Europe as the man with the golden nose. This was the prosthesis he had. But what he did was extremely valuable. He built an observatory. This was before the telescope. And this was the largest quadrant around. This observatory on that island was the first really good astronomical observatory. This quadrant had a resolution of 1 minute of arc. A degree has 60 minutes of arc. This thing could tell you the position of a star, the elevation of a star, to within 1 minute of arc. And to make the story a little bit shorter, he looked at 700 stars, and then the king died, and Tycho had to leave, and Tycho went to the court of the Holy Roman Emperor. I won't go into details here. And Kepler was an astronomer, came from a modest background, very brilliant in mathematics, this was his first model of the solar system, which quickly was abandoned. But then he got kicked out of Austria because Austria was Catholic and Kepler was a Protestant. So Kepler went to the court of the Holy Roman Emperor, where Tycho was resident, and Tycho had his data. 29 years of measurements of stars. And what happened was that Kepler looked at this, and up here, the Great Quadrant could measure the position of Mars within plus or minus a minute of arc. And after much thought, Kepler concluded that he had to believe the human eye and that Aristotle was wrong. There is no uniform circular motion. And from that, he developed the laws of planetary motion. And from here on in, I'm going to come to Isaac Newton, because Isaac Newton was the starting point of the modern age, modern exploratory age. And this simply says that the planet moves faster here and slower here, and so it's not uniform motion, and certainly not a circle. And then his other law said that here are the distances to the stars, because it turns out that the major axis of the ellipse is the cube of that is proportional to the square of the period. And once you have the periods, you could calculate the distances. And this was something that was really important. Here's a picture of the Rudolphine tables that Kepler used to make this judgment. And I've always thought that Kepler was the intellectually most courageous person. I mean, to argue with Aristotle, to say, gee, this guy is, what's wrong, was really very difficult to do. Isaac Newton, here's a picture of his birthplace here. He, very bright, not very rich, got into Cambridge by virtue of the fact that one of his uncles was a Cambridge graduate, graduated from Cambridge in 1665, and then had to return home because of a bubonic plague outbreak in England. And people knew that if you went to the country, you wouldn't get the plague because the rats never followed to the country. And so here is then what he did. He, first of all, rediscovered the binomial theorem and then developed the law of gravitation. And of course, that's the famous apple story here. I made this drawing myself. I thought it was important. But then the most important thing he did was to invent calculus. You know, the Greeks almost had calculus. There was a Greek mathematician by the name of Zeno who started to think about infinitesimal numbers. You know, he said an arrow shot at a target has to go half the distance, and that gets smaller and smaller and smaller, and I need to invent an algebra for infinitesimal numbers. He never did. What Newton realized about infinitesimal numbers is that you can't do algebra with the numbers, but it is possible for a ratio of two infinitesimal numbers to be finite. And that, of course, is the fundamental theorem of calculus. And Newton had to invent calculus to get to the law of gravity from Kepler's measurements, from Kepler's laws, the laws of planetary motion. And so this, I think, is by far the most important sorry. Okay. This is the most important thing he ever did. Most lasting, long-lasting contribution. And it's astounding. He was 22 years old at the time. Now, Newton, of course, did a lot of other things. He did the laws of motion. But then he left Cambridge. He resigned from the university because he was elected to Parliament. And in those days, the Oxford and Cambridge had each had a representative in the Parliament. And He was one. The king then also asked him to be master of the mint, and he was elected president of the Royal Society. This is the Principia, which he wrote after he left Cambridge. And the most important thing he did after that was to get this observatory built at the shipyard, the Deptford shipyard that I showed you earlier. This region here became the same kind of institution that Henry had earlier. And it was, of course, very important because the longitude problem was the first one that was solved, and Newton was heavily involved in that. Here he said, for the true determining of longitude at sea, there have been several projects, two in theory, but pretty difficult to execute. And then he said, one is by a watch to keep time exactly, but by reason of motion of the ship, variation of heat and cold, wet and dry, and difference of gravity in different places, such a watch hath not been made. And then the Committee of Longitude gave the job to the British clockmakers. John Harrison built this clock here, and the watch hath been made. So Newton was really responsible for getting the longitude problem started. He had a practical bent. I'm going to go very quickly now because I think I'm running along too much time. The first, we're going to talk about rockets, and it's mostly a picture show. The first really working military rockets were done by a British Army officer, Colonel Congreve. And of course, the rockets Red Glare were Congreve rockets. In our anthem, they were the flag of Baltimore. This is the first, Konstantin Tsiolkovsky is the first person to realize that rockets were necessary for space travel and that they had to be liquid fueled because you had to be able to turn them off as well as on. And if you had a solid fueled rocket, you could never turn it off. He also suggested that the fuel be hydrogen and oxygen. And this suggestion, of course, was picked up because the three main engines of the shuttle had hydrogen and oxygen fuel. This is Hermann Oberth. He was a German. I should have mentioned that Tsiolkovsky also was the first to derive the rocket equation. This is the equation here that describes the performance of a rocket. He was the first to derive it. The second to derive it was Hermann Oberth, this gentleman here. He lived a very long life, well over 90. In fact, I was a NASA representative to his 90th birthday party. But what was important about him, he started the German Rocket Society. They had a little experimental place. This is Oberth, and he's standing next to one of the rockets they had. And here, for the first time, is the 19-year-old Werner von Braun. The real hero of the rocket is Robert Goddard. This is the first liquid-fueled rocket that ever flew. It flew in Auverness on the farm that his family owned. And I won't go into how it worked, but it went 41 feet on March 16th, 1926. First rocket. Goddard then got a grant from the Guggenheims, set up a museum in New Mexico, in Roswell. How many of you have been there to that museum? It's worth going to. And there he built the first gyro-stabilized rocket. He didn't have the feedback time quite right, so the rocket jiggled around. but in 14 seconds, it flew up to 7,500 feet. So we now had the means to get into space. The first satellite that was ever built and flown was designed by this gentleman. This is Sergei Korolev. This is the rocket he designed to fly the Sputnik. He also designed the rocket that carried Yuri Gagarin into Earth orbit. He was the first man in Earth orbit. And I remind you that Russia is part of Western civilization, for better or worse. So this was, in the Western tradition of engineering. Werner von Braun, of course, was very important. This was a wartime thing, the V-2, the first rocket that could fly into space at a range of about 300 miles. This was a US rocket that Werner von Braun designed and built. And this, of course, is the Saturn that took our people to the moon. And here's Werner von Braun. These are the 5 rockets that lifted the Saturn on the trip to the moon. Here's Werner von Braun. You can see these were giant rockets. And of course, here is Neil Armstrong, who unfortunately died recently. Here is the Eagle, the module that carried the astronauts to the moon. And of course, I don't forget that. First man on the moon. This gentleman is Max Fouché. I'm sure some of you have heard of him. And he designed both the rocket for the Apollo system and the space shuttle. So Max was, he unfortunately died recently, but he was a brilliant, brilliant engineer. And I now get to the things that I had something to do with. This is Charlie Hall. And we at Ames had the job of building what we call the Pioneer spacecraft. This is a picture which you can't see very well, but I got a better one later, or a different one. And this spacecraft was the first spacecraft to leave the solar system, the first spacecraft to get past the orbit of Neptune. And if this is where it was built, this is the NASA Ames Research Center. It was put together in this building. Actually, a contractor did it, but they worked here. And the engineering model of the Pioneer hangs in the Hall of Firsts at the Air and Space Museum in Washington, right next to the Spirit of St. Louis and the X-15. You can imagine that we had a monster party after this. The thing was, none of us were sober. This is a different thing. This is the Viking, the first landing on Mars. This was not an Ames job, but we had the job of building a package to determine whether there was ever any biological activity on the planet. And here is a picture of the this is the first picture that came down from Mars on the Viking spacecraft. This is the package that we built at Ames to put on the spacecraft to look for evidence of biology. We didn't find any. And then, of course, the Voyager was the Grand Tour. This is the spacecraft that went past all 4 outer planets: Jupiter, Saturn, Uranus, and Neptune. And it has now gone into interstellar space recently. And Ed Stone was the person who made that happen. This picture was taken in the office of Vice President Bush when Jim Beggs and I were appointed NASA administrator and NASA deputy administrator, and here's the bond. right? And of course, what we did was, in the Reagan administration, we did the space station. And we got him to say this in his State of the Union message in 1984. Our progress in space, taking giant steps for all mankind, is a tribute to American teamwork and excellence. We are first, we are the best, and we are so because we're free. We can reach for greatness again. We can follow our dreams to distant stars, living and working in space for peaceful economic and scientific gain. Tonight, I am directing NASA to develop a permanently manned space station. And that's when this thing started. I wrote this book afterwards. Here is the space station. And Reagan wanted it to be international, so we built a little model of it and took that to the London Economic Summit in 1984. Here's Margaret Thatcher of the United Kingdom. This is Benito Grassi, who was the Italian premier at the time. Pierre Trudeau from Canada, and Nakasone from Japan. Then President Bush in '89, on the 20th anniversary of Apollo, and I'm telling these stories now to show that we're still in the business of trying to get out of our own gravity field and going somewhere else. And on this 20th anniversary speech, he said, first, for the coming decade, for the 1990s, space station freedom, our critical next step. And then next, for the new century, back to the moon, this time to stay, back to the future, this time to stay. And then a journey into tomorrow, a journey to another planet, a manned mission to Mars. And Harlan Smith and I wrote a paper, and that paper is down here, so you can pick one up if you want to get one, of how to get to Mars and how to do it cheaply. Unfortunately, it never happened. NASA didn't want to accept what we proposed. That happens occasionally. This was our schedule, and you can look at that in the paper. And I want to read the last paragraph of the paper that we wrote. Though science is important, the human imperative to explore is probably the most compelling reason for undertaking the enterprise. That's the enterprise of going to Mars. The title of the paper, by the way, is A Fast Track to Mars. Occupation of the solar system, one can argue. All of this will be the precursor of human exploration and ultimately the occupation of the solar system. One can argue why this should be done, but must conclude that the only answer is that it is our nature to do so. The great Russian visionary of the space age, Konstantin Tsiolkovsky, wrote in his notebook 95 years ago that the Earth is the cradle of mankind, but one cannot live in the cradle forever. Well, that's it. What will we find when we reach this world? Thank you.